Okay, welcome. Welcome to our workshop. And rog să pui prima prezentare starterul. Okay, I make a very short presentation as a starter and to define some terms to be on the same page about the proposed content of our roundtable. And after I invite for around 5 minutes, the participants that already send me their institution, their company presentation to have a presentation, short presentation. And after we start the roundtable with discussions, we shared some good practice, and also I think will be very, very useful if we could also share what wasn't so good, so-called lesson learned. Okay. Now, make innovation happen. It's a roundtable as a satellite event of PRIOCHEM, 18th edition. It's maturity, as you can see, organized by our institute, National Institute for R&D in Chemistry and Petrochemistry, ICECHIM, Bucuresti. First, if you discuss about if you discuss about innovation, technology transfer, let's have a short view what we propose for a short definition used by World Intellectual Property Organization that help us to protect our work, our intellectual property. Technology, systematic knowledge to fabricate a product or to provide a service in industry, agriculture, medicine, or commerce. But not all the knowledge could be inside the technology. The same institution, World Intellectual Property Organization, proposed 3 criteria to be systematic, to be in a certain place, written form or a personal intellect, and also, what is very, very important, must be directed for achieving a useful purpose. Industry, agriculture, or commerce, in society in general. Now we discuss about technology readiness level. When we look at that definition, initially, NASA defined for aerospace 9 levels, starting from idea identified to commercial deployment or a full usage in space, in aerospace field. It comes European programs with to refine the definitions and to say 5 and 6 are industrially relevant environment. After 7, 8, 9, competitive manufacturing. I could say more operational because, as you know, are a lot of debates here. Nobody is so clear what it means, 5, 6, 7, 8. Starting for some more precise, maybe more useful for us definition of European programs, to say 5, 6 is how it can be made in real life in a factory, let's say, and 7, 8, 9, how it works in real use. Now, what happens sometimes is so-called Technology Readiness Level TRL 4 wall, and it means sometimes in our R&D labs, we stop in something verified in the lab, and maybe we could not take into account how it can be made, maybe you don't know, and also how it works in use. Now let's speak about innovation paths. We start from creativity. We have good idea for new products or process. We derive new ideas in invention. After, next step, it's to bring ideas to life. That is innovation. It means we understand by innovation, only it's finished when it's successfully introduced, something new and useful has in effect, also in good market. Invention could be patentable or not, and we could say more in our labs are potentially innovative and became innovation together with a company we were introduced on the market or in society. Now, some very interesting example from invention to innovation. It was Gero Vitali in Romania, you know about. And maybe the most famous is Coca-Cola. Start from an invention of Dr. Pemberton, who sells this product only in his environment. And after passing through some steps, became a huge commercial success that make some effects in society. Maybe not good, for some people say it's not so good, but it has a big effect from invention of Dr. Pemberton to innovation. Now, technology transfer. When we start in R&D lab, we derive inventions, potentially innovative. We move that knowledge and also discoveries that fulfills these three criteria to a company. It means we've done a technology transfer. Next is how it's linked with innovation. First, we do this technology transfer, and after, the company, together with a lab, you could see how decrease the color of technology transfer, the influence, goes introduced in market. In this moment, it becomes innovation. And the R&D labs, together with a company, should go hand in hand for this process. But the question is also, how frequently it happens that? What we could find, a general statistics says from 3,000 very good idea, only one became a success on the market. Are a lot of things, not enough knowledge regarding innovation process, budgetary constraint, and so on. From perspective of innovation path, not from pure R&D, to generate good idea is a simple step. Difficulty to select the right idea and to implement them. For this is so-called management of innovation. And if we have a look at that it comes together with R&D, it means to find new knowledge that could be applied, and after to do transfer, to go to fabrication and commercialization. Something should be boring, should be not so clear, but it's not so. We could use, and what I propose mainly from this workshop, but not on, from this round table, when we start from prototype and how we do tests. And also there are some methods, statistics, verification, concurrent engineering that could help. Not only, also marketing and many others. Now, just a general idea, we have inputs that could be controllable in a process. It means we could set the value, and uncontrollables that come from outside, like temperature outside, humidity. But we should do as much as possible to simulate and to do experiments in the lab, also it is uncontrollable. And so we could derive a so-called robust design by Taguchi. In this case, you see uncontrollable input, let's say temperature, provoke a huge output swing that could be a lot of defects, and should be done from the beginning, how much is possible, to be very flat, this dependence. That is a robust design. It means uncontrollable inputs, minimize the effect of outputs. It means defects. Its defect is not a success on the market. Now, I thank you, and I kindly ask you to start effectively the round table. And I invite Audrey, you are there, to present a ICECHIM company. Audrey,
yes, I'm there. Do you hear me well?
Yes, and I put now the slides, and you please tell me what to do next.
Yeah, okay, great. Do you want me to share it as well on the Zoom link?
Yes, please.
Okay. All right, so you should see my screen now.
Correct.
Perfect. So hello, everyone. I'm Audrey Janine. I'm head of innovation at PRIOCHEM.
Audrey, sorry, you share or I share? No, you share?
I already shared it, I think, on the Zoom link, if it works.
Let's maybe to share us to go faster. It's okay.
Okay, perfect. No problem.
Okay,
And I will
thank you.
Yeah.
You see the screen? Let me know. You see the screen?
We see. Yeah, I think we see it. Yeah.
You see your slides?
So
okay, great.
yes, okay.
Please proceed and tell me next.
Okay, perfect. Thank you. Yes, so I would like to take this opportunity, thank you, for sharing our feedback as a starter, developing an innovative project to accelerate the transition to regenerative agriculture. So next slide, please. I will just give you a few figures to start with so that you understand the context of agriculture and why we are developing this project. So if you can move to the next slide. Yep, great. So just to let you know that today agriculture is considered as the first natural carbon sink in Europe, while also standing for 70% of our food carbon footprint. So there is a huge challenge in agriculture to leverage the carbon storage potential and also the reduction of GHG emission in order to mitigate climate effects. So next slide. Our mission then for that is to leverage carbon finance to make sustainable agriculture attractive to farmers. So next slide. I think it's slide 4. Yeah, just after. Yep. So what we have built so far in order to make a sustainable agriculture attractive and ease the access to carbon finance for farmers is an automated and integrated digital solution through a platform, which I will just show you in a minute. And behind that, we also have developed monitoring, reporting, and verification infrastructure. And in order to do all of that, in about 2 years, we constituted a team of 18 people. I will also present you our organization just after. So next slide. Here you can find an overview of our platform, which is basically a tool for farmers to measure their carbon footprint and identify the different practices they could adopt to reduce their GHG emissions or to improve carbon sequestrations in soils and estimate a carbon potential from the practices they identified, and then turn them into certificates that RISE is going to sell to companies that are willing to mitigate climate change effects and so contribute to climate neutrality. And then RISE will take that financing and give it back to farmers for their efforts. So next slide. Behind what we have, as I was mentioning, is an overall technological infrastructure composed of mainly 2 things. On one side, you have carbon calculation models. And then on the other side, we also have traceability capabilities using satellite imagery to bring external validation to our farmers' declaration. And now our team, so next slide. Just to show you how we are organized. So we have mainly 4 groups. One group is in digital. We also have carbon expertise with a scientific team. And on the other side, we are developing partnerships to deploy our solution and innovation projects. And also we have a team leading the operation side with our customers. So now tackling the subject of innovation, what we use, basically is the discovery process, the customer discovery process, which is done in order to continuously refine our ideas, understanding deeply our customer problem. So really getting into what are their pain points, their desires, and their current needs. So what we do is continuously interviewing our users, and then prototyping, of course, with different types of prototype. Some prototype for testing the usability of the solution, but others also for testing the idea in itself and how the data input is, how easy and smooth is the data input. And of course, testing the value of our solution can also be done through, for instance, getting letter of intent or assessing the time spent by our customers. So these are also other examples to continuously test and refine the value we can bring to our customers. And then next slide, this is what we have concretely done following this discovery process. So you can see that before we were established in September 2020, we conducted a field investigation with lots of interviews, scientific literature review, and so on. And then the first prototype that we delivered in 2021 was first to test the data inputs. So we learned a lot about this, and then test the UX. We also get a lot of feedback on how farmers interact with the tool, how we can ease the process. And then we delivered a final prototype in July. And from there, we launched a pilot phase with partners such as cooperatives or farming product traders, which deployed our solution to more than 300 farmers. And we also get key learnings from that pilot phase, and especially the fact that the data input process is a huge pain for farmers. It is time consuming, and sometimes the evidence collection is not suited to their actual available data. So what we decided after that is to deliver a second version of the platform, which corresponds better, which matches better their field data. And this is where we stand now. So since several weeks now, we are developing a new version of the platform with a simplified process. And coming to current pilot projects that we are actually carrying out in Romania. The idea here is to test a financing scheme for carbon farming applied to Romanian farmers. And basically, so we are doing this project with partners Raiffeisen Bank and Rotunda within the frame of the Elevator Lab competition. And the idea is to test three things. First is to assess the interest of Romanian farmers in carbon farming and assess as well their potential in generating carbon. Second is confirm technological feasibility. And third, to qualify Raiffeisen interest in carbon finance. So I will come back also to that if you're interested. And last but not least, our current innovation activity is also to assess the opportunities we could have with the food and beverage industry. As you may know, there is a huge challenge in securing our current food supply chains. And one way of doing that is through regenerative agriculture. So
thank you so much. Thank you so much for your presentation. Sorry, but we need to make
time is running fast.
And very interesting. And one simple question: you say strictly private and confidential. I think that doesn't apply because you are in a public presentation. It's not for us, yeah. Strictly private and confidential. We don't have an NDA with you. Sorry. We disconsider what you said that, yeah, because you put in a public discussion, limited but public, yeah.
No, it's okay for public. Yeah.
It means don't mention, I think you don't maintain strictly private and confidential. Yes, isn't it?
It's okay. Yeah, it was automatically written, but it's fine.
No. I know what I work on a huge corporate channel, and I know what that it means when you have an NDA. Okay, we'll discuss later, because you also ask if you like to share also with participants after. Okay, thank you so much. We come back. And now I invite Professor Adrian Tulbure from University of Alba Iulia. Professor Adrian Tulbure is also the director of Center of Technological Transfer in that university. We have long time cooperation. Professor, hello.
Hello.
Here. Okay, Professor Tulbure is engineering electronics and electrical engineering, has a huge experience and practical assessment. He will present for you. Alba Iulia, UAB. Alba Iulia, UAB, que é jos.
Okay, thank you for the introduction, Mr. Nicky.
Okay, welcome. Do you see the screen?
Yes, I see you.
Just a
I
second.
hear you and see you.
Now I should see your presentation. It's okay?
Yes,
Okay,
thank you
please
for the
proceed.
invitation.
We thank you for your participation. Please proceed.
I want to present my university and our Technology Transfer Center. We are located in the central region of Romania, in the middle of Romania. You hear me?
Please mute who is not speaking.
Nu știu, e acasă cu taică-su.
Please mute.
Lena,
Da,
please deactivate your.
păi da, e un pic, încă nu i-a trecut.
Please mute who is not speaking.
You hear me?
Okay, please proceed, Adrian.
I want to present my university and my town. We are located in the middle of Romania, about under 100,000 citizens in Alba Iulia. Science third, we have a university, and at the university we founded 3 years ago a Technology Transfer Center. In total, at the university we have about 5,000 students. Bachelor, maybe half, 2,000 until 3,000 students, and master and doctoral PhD students also. Please, the next slide. Yes. I want in this time to give you an overview, about our research, our development activities. Of course, we are a player in this game about founding in research and development, Horizon 2020, and internal and external international foundries also. You can see in this slide the most relevant research, development, innovation, and technology transfer grants. Like we are focused in the field of machine learning, artificial intelligence, because we have students in computer science, in Romanian language, as in English language also. We have some activities in the field and artificial learning, some about the innovative technologies concerning recovery of waste material, and data fusion and data mining also. research projects, European financial support. On the other hand, we have in the university strong relationship with companies, with the industry in the region. We was signed maybe over 10 or 12 contracts between university and industry, in special with automotive companies, Benz, Continental, Bosch, and so on. I want very much to make some advertising about our two centers. We have two certified, two accredited center. Please, next slide, please, Nikki. One of these is a Center for Research in Electronic System and Intelligent Control. You can see some research grants with in framework of national scientific plan, and also in framework with financial support from Brussels, from the European Commission. Another certified center accredited, please next slide, is a Technology Transfer Center. I am the director. I am responsible for this center. After my work in Germany, I come back at the university in Alba Iulia, and now I am professor for power electronic and electronic measurement. We carry out some expertises or some audit and reports in the field of energy, micro and mini energy grids. Also, we are certified in the field of environmental audit and technical audit. So, since 2 years, we are accredited from the Ministry of Research and Innovation in Romania in the field of IT, in the field of environmental and climate, and in the field of automotive and mechatronics. One word more, we have collaboration in more levels with the industry in our region. We make together some courses, some classes, like Bosch or Conti Academy. You can see in the slides, not only teaching activities, but also research and more innovation and development as research. We have together with the industry 2 PhD students in framework of industrial doctorate program. Thank you for invitation, and we are ready to
Professor
participate in the future with our expertise.
Thank you so much, Professor Adrian Tulbure. You have an outstanding experience, and also, as I mentioned, we have also our institute, ICECHIM Cooperation for History and Patrimony Museum University to rehabilitate the wonderful Alba Carolina. Yeah. Thank you so much, and stay with us to make some discussion further. Now I kindly invite Professor Cornel Cobianu, outstanding researcher. Now he's member of Romanian Academy of Scientists, and he was first scientific director of National Institute of microtechnology, and after first director of a lab of sensor and wireless in Bucharest for Hanuel, chief scientist, and now he's with Academy of Science, being vice president of a section of information technology, and also it's a company that he will present now. Perfect. Please, Professor Coviano, please proceed.
Thank you very much, Dr. Baraciu, for inviting me and our company NanoMEMS to present here a few words about the company. The company NanoMEMS was founded in 2006 by Dr. Marin Gheorghe, with a PhD in chemistry in ICECHIM, Belgium. This is a small company involved in research and development, with very active participation in national and European projects. The company has a good expertise and good technical capabilities for nanomaterial synthesis by different methods like co-precipitation, hydrothermal, sonochemical, chemical bus deposition, just to mention a few of these methods that we can use in the company. Also, the company can do research in the area of thick film and thin film technology for screen printing, and inkjet printing can be also applied for the fabrication of thin and thick film needed in solid state devices and sensors. In addition, the company is well prepared to participate in European projects related to sensing technology research in the area of chemical, biochemical, also mechanical, optical, and MEMS and NEMS devices. Also, we can say that the company is well prepared to do a very deep technology radar in a different research field, and then such a technology radar to be accompanied by concept development and new device innovation. Thanks to such an agile behavior of our company, we are now involved in very important European projects, like the project we mentioned here indirectly by the team involved. It's an FET Open project related to transdimensional films for optical applications. In this project, we are partners with Tyndall, with CNR, Nanotech Italy, and Cantabria, and a few other companies. But I have included only this because this was the key team that developed intellectual property for the project. Next, please. Regarding the title of our roundtable, I consider very important for the second part of discussion to have a more a deeper analysis in what you need to have an innovation process at the organization level. In any company, you may find people that are good in developing new concepts, but this is not the whole truth. What you need, actually, you need to trigger the innovation at all levels, from the fabrication level up to the highest level. So this is the most important concept that is concerning nowadays all the companies, from smaller companies to highest companies or biggest corporations. So that is just a starting point for triggering more discussions. And the second important aspect of innovation is a change in the way we are leading a company from the CEO level. And this is called now hybrid management, where the CEO is not only the people, the man and the scientist that is having a vision on the future, but it's also able to promote this innovation approach starting from the lowest level and to give trust, courage to the people to become innovators. And this is CEO as an enabler. Probably we can talk more in the second part. But coming back, next slide. Now we just want to show what we are doing in this area of innovation, because we want to stick to the idea of innovation. And from this reason, we present here, for example, what we did in a Romanian project. In Romanian project, we had a project together with National Institute of Physics of Materials. And here you see a list of patents that our company has registered at ICECHIM in the area of pellisto, or chemical gas sensors for methane detection. So this is an example about the innovation that we did in a Romanian project. Next. Here we have another examples of innovative contribution of Nanom in one of the European projects we developed. We are member, that is a FET Open project. You know maybe more about FET Opens. I will not insist on that. But here in this project, we have disclosed 2 patents, European applications. The first one is multi-band multipolarization plasmonic photodetector and fabrication method. And the other one is regarding the reconfigurable plasmonic photodetector and fabrication method. Here it's exactly what we discussed before about intelligent intelligent innovation and collective innovation. Next slide now, it's probably the last one that we want to talk now is regarding another innovative approach in another European project where Nanom together with Tyndall have disclosed the patent regarding self-power on chip integrated sensing, nano and microsystem fabrication method for the same. So I stop here. I just want to prove what I said at the beginning, that Nanom is a contributor and an innovative company which is now in contact with partners from outside. We are talking now with an UK company and try to further offer a license maybe on pellister technology we develop. Also, we talk about the same things with another group in France. So we want to push forward our innovations, and hopefully someday something will happen. Thank you, Mr.
Thank you, Professor Cobianu. We have 45 minutes left, and maybe if you could present shorter and after to have a discussion more. And now I invite outstanding private company, DDS Diagnostic, and Dr. Lorena Bocancea-Mateescu. We have long cooperation in research with this company. It's involved also in research, but also in fabrication. They have success on the market, on testing. They will explain to you. Please, Lorena, proceed.
Thank you very much for your kind words and for including us in this event. Yes, I am a member of the Research and Development Department of DDS Diagnostic, which is one of the most innovative Romanian biotech companies for in vitro diagnostic, and was founded in 2002. Next slide, please. Can you hear me? Thank you.
Yes, please.
Thank you.
Yes.
So some of our major objectives are the development of new test technologies for rapid in vitro diagnostic We want to improve performances in terms of sensitivity, specificity, and accuracy. We are also focused on immune and molecular diagnostic in the point of care domain. We also want to develop our production sector and international sales, and of course, the funding expansion via private or even European grants. Next. So what is our vision? Our vision is that everyone should benefit from faster, accurate, and accessible diagnosis by getting easier, precise, and affordable rapid tests to either take in hospitals or clinics or even in the comfort of their own homes. The right moment is now because the COVID-19 pandemic has accelerated the certification and entering on the market of this type of tests. Next slide, please. So we have 6 departments. We have a production area, we have sales and marketing, logistics, research and development department, as I mentioned, technical support, and regulations. Our main purpose is to provide affordable, efficient solution for medical laboratories. We develop and manufacture and sell original tests and equipment for rapid and accurate diagnosis for various pathologies. We are also involved in various research projects in the bio and nanotechnological field, and we aim to adapt and improve our products constantly. Besides these projects for improving our own products, we also want to open the road for new technologies. We are currently working with electrochemical biosensors. We have an application using screen-printed electrodes for in vitro diagnostic purpose. And the results show us that this is a very promising platform for the future of quantitative testing. And also they have impressive sensitivity in terms of detection limits. They can detect target analytes in concentrations far lower than picograms. Next slide, please. Oh, and I forgot to mention, we recently entered the therapeutical domain. We are currently engaged in an application with hydrogels. We incorporate various components that can confer them a dual effect. For instance, wound monitoring and also curing. The main problem as we see it is that people most of the time receive delayed screening and diagnosis. The reasons for this problem are inconvenient access, overcrowding, and less available physicians. Of course, the services are becoming more expensive also, and we all know that a late diagnosis can significantly reduce the chance of a cure. Next slide, please. What we can provide is immediate diagnostic through yes or no qualitative testing that can be carried out at home or in a convenient place and are much more affordable. Next slide, please. So I'm not sure how many of you are familiar with the basic structure of a lateral flow immunoassay, but they usually consist of membranes, which are made from different materials, and they overlap each other by just the right amount, and are mounted on a backing card using an adhesive. Additionally to these membranes, they also contain a bioconjugate solution, which is composed of a labeling molecule and a detection molecule, and an antibody solution for the test line and another antibody solution for the control line. Now, these lateral flow immunoassays are becoming very popular, basically on the front of the recent pandemic with SARS-CoV-2, and they're very easy to perform. They imply very low costs, and they can be used for the screening and diagnosis of a series of diseases. There are two main types of lateral flow tests: the sandwich type, which is very similar to an ELISA test, and the competitive type, which is mainly used for semi-quantitative and quantitative tests. The positive sandwich tests are represented by a presence of a color line in the test area, while the positive competitive tests are represented by the absence of a color line in the test area. Now, we all know that nanotechnology can play an essential role in different personalized medicine applications, and lateral flow immunoassays can be included in what is in trend right now, telemedicine, that can allow healthcare professionals to evaluate, diagnose, and treat patients from a distance using telecommunications technology, such as our smartphones, for example. Now, these kind of tests are very versatile. They can detect various target analytes with very great accuracy, such as hormone, viruses, microorganisms, biomarkers for cardiovascular disease or cancer, parasites, and even fungal infections. Besides this versatility, they can also be used not only in the medical sector, but also in the agricultural sector or even in food and animal feed, for instance. We have, like I said, we are very involved in research, and we have various partnerships with research institutes. We have all the necessary certifications to access the market, and we have production, sales, marketing, and logistics departments, and offer support to our clients. Thank you very much.
Thank you so much. For details, if you agree, we'll share also with participants your slides and they could contact, and also our institute as we start discussion with okay to work in biosensors as we discussed. And now I kindly invite Dr. Cătălin Pârgulescu for National Institute from Microtechnology. Okay, Cătălin, you are with us? Oh, Cătălin? 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 Do you hear us? You are on mute, Cătălin. Ia vezi dacă e Adrian Popescu, Florin Popescu, mai jos, Popescu. Nu este. Cătălin, you are with us? You are on mute if you are with us. Maybe you are first scientific director. Do you like? Maybe to go a little bit faster. I tried to present myself because 3 months ago I was there. Could you, Cătălin? Okay, let's go a little bit to show. Next presentation, Florin Popescu, you are with us? No? I present myself, our institute. Checking the PowerPoint, la round table, No, aia. Asta e? Ia, asta era round table, da? Okay. Okay. I try to go a little bit faster to present our institute. Please, next. Our institute has over 7 years of experience, was founded by outstanding scientists, led by the famous all over the world professor, member of Romanian Academy, Costin Denenițescu, well known in organic chemistry. If you look in 2004, we became a National Institute of R&D. Looking at numbers, there are 120 researchers, 75 of them are PhD, and from this PhD, 7 are PhD supervisor, it means doctor habilitat. This is an interesting scientific background of our institute. Please, next. But we see also stay very good in applications. We have applied research projects in practically a lot of areas, as you could see. In heritage and culture identity, we have good cooperations with Center and with the University of Alba Iulia, as I've mentioned. Please, next, please. A lot of published research, granted and requested invention, also technology transferred, more work together with private companies that we obtain final products that are on the market. Next, please. If we look at the area, technical area, capitalization of bioresources, nanoscience, nanomaterials, environmental protection, sustainable management, and also very important our days recovery, and after recycling and valorification of byproducts, and working from increasing competitivity of industrial products, and why not to refurbish the times ago outstanding chemical industry. And in what we trust, all others bring data. We have in 2021, 30 products, 27 technologies, 2 technological services, all have patent applications we received from years before granted patents, and also 43 award-winning participation at the international innovation and invention exhibitions, from where 22, more than a half, a little bit more than a half, are gold. Our infrastructure, laboratories, and also, it's good to know, we have accredited laboratories for chemical analysis by RENAR, and we are part of ERIS, engaged in the European Research Infrastructure System. Please, next. And we could find on this address that we'll send to you, where we engaged with, we find number of services, equipments, experts, the fields, practical, the main fields of expertise of our institute. And we have this structure that is in this ERIS, the consortium, let's say. This next. And if you look in our page, www.ICECHIM.ro, you find technology transfer centers is on the first page. Please, next. And in this, we could find more details. Please, next. And now we run a project by this technology transfer center, development by innovation with South region and with companies, and we do start to do technology transfer. We prepare that, and also increase our capability of our technology transfer center. Please, next. What we're interested in cooperation, network twinning, and sharing experience, good practice. I think we have not too much time now, but we'll share presentation, and I'll be happy to keep in touch. And why not to write projects, to write more details about, to find more details to be together for a consortium, and also with company to transfer technology to go to make innovation happen, as we discussed. Who is online and didn't present yet, please? Dr. Florin Popescu is? Cătălin Pârvulescu, you are there? Okay, I send their presentation. And now the floor is open. If you like to also from the room, we are also some colleagues here in ICECHIM. If you like to say something and to share other, I have also prepared some aspects here. Or maybe this is someone who I sent also the presentation of people who could not attend, but I see Cătălin, it's online, maybe has a technical problem, but don't worry, I sent to all their presentation and their data. You could stay in touch with people. Now we have a half an hour to have discussion, maybe less, because at 3:30, Stefan, it is another, yes, will be another. Maybe 25 minutes, because you should switch, but okay. Now the floor is for all of us who like to share something. I also prepare something. Maybe if it's not, maybe to show you something that I discussed. Robust design, if it's not, please. Please click here to show what I mean. Yes, let's share. Very few to little bit to show you what I mean by these methods that I propose to be shared. When we discuss about the design of experiment, it was first derived in years 40s in agriculture, because in agriculture in London, it was a research institute of biotechnology. It takes 2 years sometimes, and they have no time to lose what we have done. And it was done by Fisher. Please, next. What it means, we vary together the inputs, not one factor at a time. Please, next. Next, a next slide. Okay, a next slide to be more simple and explicit. Okay, next to be full. Okay, next, and next, and stop here. When we do generally, we do one factor at a time. It means if you have two value, low or high, for instance, 3 milliampere, 10 milliampere, 10 degrees, 100 degrees, generally we put in one factor at a time, all at one level. We vary only one at a time, 4 trials. If you do all together, how it's said, we have like making in the binary, when it is 0, 0, 0, 1, 0, it means 8 trials. What is a huge difference between that? If you do this design of experiment, it means all this combination, we could capture interaction, and this will be benefic for robust design. Please next. And here it's a real life example that I worked many years ago. I don't, please. Okay. Okay, how it was done, you see, it was for a material, it was pressure cycle, two different way to do. Here it was gasification, degasification, 2 level of temperature, and we have eight trials. And if you do here, it was 4 different forms, 13 cycles. Here is blocking. It means you do principle of experimentation. We separate what we know are homogeneous, and after here it was replication. And what we have obtained, here it's important, what we discuss about robustness or to reduce cost. Please see in the left side, when we have its interaction between 2 cycles and 2 levels of temperature. What it means, this interaction, because the lines are not parallel, because in analytic form, you find they are in product. Next, okay. And what you could do here, for someone, okay, indicator the ecran, okay. It means if you look at left side from cycle 555 120, it's a small variation of output when you have a big variation of 10 degrees of a temperature. Opposite, other cycle is a much larger variation. What it means, if we set on the left side, our manufacturing cycle is more robust because we should not fix the temperature very precise and very expensive. It's a huge difference. That is a kind of robust design for manufacturing. Also could take into account for output. Okay. Now, if other one likes to share with us some experience or to some comments, please. Hello, Catherine, you are back? Maybe has problem with communication. Okay. Body, I have other examples, but maybe I like Professor Tulbure to explain us more, because I was in Alba Iulia and it was amazing what I find there regarding the link with academia, with Bosch Academia. What are you doing with Continental? How you support this company direct? It means you are inside innovation path. Please, Professor Tulbure, could share with us.
Yeah, Alba Iulia is a small town. Where we are happy that we have a good connection, strong connection with the industry. Alba County is in the list on the 4th place as export pro heat in Romania. In the auto, and with this background, close some collaboration with automotive companies in all the level, all the levels. science 3 years, we started the Bosch Academy. I mean, 7 modules, teaching modules, which are held from the specialists, from the managers from Bosch in Romania at our university. We see a very successful and very future-oriented collaboration between university and industry. On the one hand, on the other, we are able in our 2 centers, certified center, research center and technology transfer center, we are able to carry out some measurements. Actually, in the energy field, we are able to measure between microwatts and megawatts in the values, and in the frequency 0 and 3 gigahertz. We are able to catch, to try and to measure energy in this field. If the energy comes from biomaterial or from biogas or from energy grid, it's egal. We have some experience with energy measurement and electrical magnetical field management. And in the IT domain, I mean, to measure bit train, bit impulses, and so on. We are ready to collaborate with your institute. And I think if you put together our competences in the domain, in the field of electronics, measurement, and biotechnology and chemical technology, is a background and good starting point to apply for European foundries, for European projects.
Thank you so much. Very good idea, and we hope to extend our cooperation and also to be close to industry who stop at the Carpathian Mountains, hardware especially. Yeah? You are very close and good cooperation with
I think if we
companies.
are interdisciplinary and pluridisciplinary or intradisciplinary, we have more chances to achieve and to obtain some financial support.
Thank you so much, Professor Tulbure. Catalin, you are back? No. Okay, I kindly ask Professor Cobiano, because he put a very provocative slide related strictly to innovations that we propose. He also prepared a lot of slides related to scientific work, but I share with you, as he likes to do that. Now, please come here to be seen. Please, Professor Cobiano, explain more what you mean by that and what you intend to provoke us with that concept. Please, Professor Cobiano.
Thank you again, Dr. Barakio. Thank you again for inviting me. Yeah, I was very pleased to see this topic launched by this round table, Make Innovation Happen, because I think this is the key for the present times and also for the future times. Regarding the innovation, we've been together with Dr. Barakio in Honeywell for many years. And in such a big company, corporation like Honeywell, indeed, innovation was a requirement for us. It was actually for the first time in our life when innovation was required. Working in Romania before that, or even before '89, nobody was saying to you that, yes, we do so to innovate. It was just like a hobby, or when I was working in microelectronic company, I was doing a few Romanian invention, and I do have them, and I'm proud of that time. But nobody asked that. And coming to Honeywell, I saw how important it is that someone to be interested in innovation, just to require to do innovation, just to reward to do innovation. And this is actually the key that I would like to talk with all of you, to challenge you on this direction, and to hear from you your experience in this field, because innovation is key. And this innovation as a key tool should start, of course, from the highest level of the company, because otherwise it's something, again, one-man idea, and nobody look at that. So it's important to have a connection between the CEO of the company and every worker in the company. When I say innovation, it's not only to do the highest invention of the world. Innovation means to do the best of your job in the place where you are. And you to be CEO of your job, you to have ideas, you to feel responsible for your job there, and you to want to improve yourself every day. So this is in my mind what means innovation. But definitely this is a very complex concept, because it is related with a kind of liberty, a kind of change in the management style. You have to change the paradigm from a management where the CEO is the ruler. He dictates everything, control everything, and knows everything. So it's a totally opposite. When you want to be a CEO of an innovative company, you have to change yourself as a manager first, and then you have to be humble, to be an enabler, as I said in the previous talk. So these are the things, and I would be very curious to see how other people are considering this innovation process. Speaking from the point of view of innovator, it's very important that you see that someone really want to push your innovation. We've been working with company, all the factories of Honeywell, most of them or some of them, and we were always quite eager to see that our innovation are applied in a way. So and sometimes
and make results. It means, because we discuss innovations, is not only to present something nice, but to have at the end of the day results to be on the market, and that it happens.
Yeah, exactly.
Not people to remain only we present and we are part. A company is a factory to manufacture and to be sold. In a way, it was simpler, in a way, Cornel, to be honest, because you have a huge marketing, and they say, do that.
When we said that we've been working with Honeywell companies, they were coming to us with a certain topic, and that was related to the market and their production, the future production. And it was a very complex process, and it is a very complex process, but those companies that really find a way to keep motivated the innovators, to connect the research with a certain requirements in a company in the market, that is the key in the end for the success at the organization level, and even for satisfaction.
And maybe to share with our colleagues of this round table, I remember when I stepped in 2004, you are the boss as a senior technology manager. I remember we start working for pressure sensor that should be delivered on the market in many years before the legislation requires that. It means look also at the change in legislative requirements, because now everybody has a pressure sensor entire, but that time wasn't. And I remember we start working on that many years ago. It means look around. And for small companies that we discuss with now, and for university and R&D, it's not so easy, but you should do that. We should also look at trends, market, and also needs more than requirements, because who find the needs and fulfill it, a problem, to solve a problem, like also our colleague of roundtable from DDS say, that is a problem. We start from the problem, what we need to solve, what it's missing. Okay, thank you, Professor Coviano. If someone look to add something. Nobody? Maybe I share with you maybe a small example of what it was the main proposal initially to methods. Share this one, please, Stefan. Yes, it means an example that I work with is from a project of technology transfer from IMT. I don't know why he's not linked with Catalin. And yeah, next. It was a project that worked with activity to be developed in cooperation. Yes, and it was with a company. Please, next. And it was interesting. We proceed. Actually, it's the principal investigator was Catalin, my colleague, Dr. Catalin Pârbulescu, and I helped with this methodology. It was to do some nanotubes for sensing, and it was 4 inputs with low and high level, and we measure length, diameter, and the wall thickness. It means to control the dimension of nanotubes. Please, next. Here it was reduced factorial. It means because there were many in the long time for each trial, for each run, we do a reduced one with to replicate and one central point to see how linear it's. We do these measurements. It was very attentive and a very good experimenter, not only like say scientist, but very good experimenter, part of experimentation, Catherine, done. And please, next. And we derive some statistics with Vinita program. Please, next. And what we find here, it's very important. We find transfer function. It means we find how it depends the dimension on inputs, and we also could see, please, next. Next. Yes, here is much better to see what we start discussing. I suggest what it means robustness. If you look here, from instance, to voltage to distance, you could see if you could not control so good, let's say the voltage, or it's very expensive, let's say you use 4 for distance, or the variation from 20 to 40 volts provoke a small output variation. Opposite, if you need the other one, or you need more robust design, for example, not to depend on distance, you should choose 20 volts and not 40. And what is good, you have a transfer function. Please, next. Yes, and here we get, yes, stop. You get a nano, perfect. You get a nanotube dimension. You could control from fabrication process, and you get by dimension initially resistance and capacity. Please, next. It comes the combustion gases. It's change the value, and if are separable using today it's called artificial intelligence. I say the recognition I do for 30 years, and I didn't say it's artificial intelligence. Now everybody says artificial intelligence, almost everything. Okay, please, next. And you could say what kind of gas. It is also presented. Okay. Thank you. Is someone who would like to do some comments? Okay, maybe next time we could stay also in a discussion in link to share from us. It's if you like to share, someone, Audrey, if you like to share something with us. Hello, Audrey, you are there?
Yeah, I'm there. Yes. Yeah, maybe I can share about our lessons learned from the discovery and pilot phase that we conducted. So as I was mentioning, we have a huge challenge in incentivizing farmers to adopt regenerative practices. And one way of doing it is through carbon financing. So the question is how is that process to get carbon financing. And through our platform, when we deploy it during the pilot phase, main learnings were that they have huge pain in inputting data, finding all the relevant and available data which are needed for carbon calculation models. So what we are currently improving now is this process, simplifying it, while still having the robust calculation methods behind. So this is where we stand now, simplifying the process on the farmer side, on the user side, while still having robustness, scientifically speaking, in our technological infrastructure.
Thank you so much. I think if nobody like to share, we'll stop here because we have in 5 minutes another meeting or not a round table, it's a workshop, also a satellite event. Also, if you like, you could attend also this one. But if I have your permission, I share with all participants all slides. All those people who could not attend or was Catalina, you are there? No. Okay. But I present a part of the common work in the important part related to innovation. It means how could do a robust design or to control the design in manufacturing environment. So I thank you so much. Keep in touch, and I wish you a lot of success to make innovation to be happy happen and to be happy. Okay. Okay, see you, and sure we'll stay in touch and we cooperate. Thank you so much for all participants. Thank you.